So good evening, everyone. My name is Yigal Goldfine, and I'm VP of Research and Algorithms in a company called Panda Logic. First of all, I want to thank Umit for setting up this meetup and for investing.com for hosting us. And when Umit asked me to speak before you, in front of you, he told me he wanted something a bit different, since this meetup is called Big Data Demystified, but he told me trying to expand the agenda and bring external content here, and that is why I'm here. So I'm going to talk to you about something called biomimicry. Biomimicry basically is innovation. It's inspired by nature. Then I'm going to talk to you about my specific company, about Panda Logic, which is a programmatic job advertising platform. And then I'm going to introduce you to an algorithm called Flock, which is basically an algorithm based on flock of birds. Okay. So let's talk about biomimicry. There are many definitions for biomimicry, but the basic term is it's mimicking nature in order to achieve either a solution for a problem or an innovation. And it's used in many fields, in engineering, medicine, transportation. I'm going to show you some examples on transportation, and of course in computer science, which is part of our world. When you talk about biomimicry, I think one of the most common examples is the wing of an airplane in engineering world. And I'm going to show you two different inventions. One of them is the Japanese bullet train. The Japanese bullet train is a train going over 300 kilometers per hour. And it was created in 1991, and it had a big problem. The problem is whenever the train went out of a tunnel, it created a very noisy boom. And it created a problem. It was influencing nature, and it was waking up the villages near the train. And they tried to find a solution for it. And one of the engineers of the train was a bird watcher. And he saw the kingfisher, which dives into the water without splashing. And he tried to mimic it, and he created a train. So the front part of the train is the same as the kingfisher. And it actually prevented this boom. And it even saved between 10 and 15% of energy. Another example is the Mercedes Bionic car. They created this car in 2005. And the rationale behind this car was to be more aerodynamic and to mimic the blowfish, the same way he goes through the water. And when they done it, the engineers of Mercedes actually diminished the nitrogen oxide emission, which was not planned, but was a nice surprise for them, in around 80%. Okay, now let's go to our world, the computer science. On computer science, there are many algorithms which are inspired by nature. I think one of the most common ones, or the most popular used today, is the deep learning or neural networks. Basically, it mimics, or to be more accurate, it is inspired by the human brain. The same way the human brain has many neurons which communicate with each other, the same way the algorithm has many neurons or cells which are connected to each other. The thing I want to focus about is something called swarm intelligence. The basic concept of swarm intelligence is a behavior of decentralized or independent organized creatures, both natural or artificial. You can see a colony of ants or colony of fishes, or even a flock of birds, as I'm going to talk about later on. Okay, before I'm going to talk to you about Panda Logic, which is the company I work in, are there any questions? Cool. So let's take it to the use case we need. So Panda Logic. Panda Logic is a programmatic recruitment advertising platform. Basically, the use case is a publisher publishes jobs Could be 1, could be 10, could be 100, could be 1,000 of jobs. Take X jobs, and you need to invest Y dollars. For instance, 100 jobs and $5,000. And our claim to fame is to bring you or provide you as many qualified applicants as possible, okay, in a cost-effective way. We do it in 2 ways. First of all, we are a platform, so we do have users, we do have our own job seekers on our platform, and which we, of course, provide. The second way is we invest money outside. Could be Facebook, could be LinkedIn, could be Monster, could be any other external vendor. You can do it yourself, but we're probably going to do it better. Okay, when I say better, I say, first of all, we get access to more applicants, and we're going to do it in a cheaper way. Because you can achieve the applicants, you can post your job on LinkedIn, but I guess our bid's going to be lower. Now, about some of the challenges we have. First of all, when you create a new product, there is an issue of the volume of the data. Okay, when you start accumulating data, not always you have like big data, as we mentioned before, and not all algorithms or all platforms can serve you as well as you want it. Second issue, second challenge is the validity of the data. The recruitment world is changing very rapidly. Data relevant to 2, 3, 4 months ago is not always necessarily relevant right now. The data is very fragmented. A job of, let's say, blue-collar job or a director in another company, not exactly the same ballpark, not exactly the same rules. And sometimes some of the data is simply lacking. If someone gave his resume to a company, I'm not sure what is the destiny of this resume. Was it good? Was it not good? I'm not sure. Not always I have the data. Another challenge is the business challenge. Not always the customer knows what he wants. What is the goal? If someone publishes a job, what does he really want? Does the most important thing, the quality of the applicants? Is it the amount of the applicants? Maybe it's the velocity of the applicant flow. Or maybe it's just cost effectiveness. So each customer could be pretty different. So we wanted to find a solution which can work on a small population, like take 1 job, or 5 jobs, or 10 jobs with a specific payment, but it will be robust. So when I say robust, could be up to 100,000 jobs at this point. And we do need a flexible solution, which means some customers, some publishers will have multiple goals, and some of them will change the goal as they go along. Okay, are there any questions so far? Okay. So now let's go back to the swarm intelligence and talk about the flock of birds. So a flock of birds, they migrate from point A to point B, okay? And the resources are limited. They don't have a lot of food, a lot of water, and the time is limited. They need to get there before winter, okay? So they're going south, and they have limited time and limited resources. Now think your job is to write an algorithm telling each bird on each moment where it's supposed to be positioned. How fast should it go and where should it go? When you handle 5 birds, maybe you can handle it. 10 birds, maybe you can handle it. 1,000, 10,000, I don't know, 50,000. Could be tricky. Okay. This algorithm called Boyds. Boyds was invented by graphical designer worked for Hollywood called Craig Reynolds. The Batman is because he did the graphic design for Batman in 1992. Okay, he created an algorithm called Boyds. The algorithm is actually a bit different. It treats each bird as an independent creature. And each bird does not know it's a part of a very, very complex ecosystem. It knows only the part around it. And it has very, very simple rules. It needs to follow a very simple set of rules. Okay, in order for this algorithm to work, each bird should follow 3 basic rules. The first one is alignment. Okay, alignment means each bird looks at the birds around it, and it goes to the average direction they go. So if they all go south, it goes south. If they go west, she goes west. The second rule is cohesion. Try to put yourself in the middle of all the birds. So if you see all these birds, go exactly to the middle. And the third rule is separation. Don't collide in any bird. Okay, and the result could be a very complex structure. Okay? So this is an example of a structure in which the bird she doesn't know she's a part of a complex system. Okay? So what you see here is the original algorithm from 1986. This is the way it goes. Each bird follows the exact 3 rules I showed you. And as you see, they pretty much go in a random way. However, it is structured. There are rules. Okay, they're not going independently completely.
Is there a purpose?
Great question.
Please repeat the question for the video.
The question was, is there a purpose? In this original algorithm, there was no purpose. Now I'm going to show you the second one, for which there is a purpose. Mm-hmm. Okay. So the question was, is there a purpose? And the answer was no. But this algorithm is built like you can add both a purpose and both, let's say if you talk about a flock of birds, you can add a target or a source of food, if you may, and a predator, something to avoid. Okay, and in this way, you can see the flock of birds going after the food and avoiding the predator. Okay, so this is the basic concept of the flock original algorithm. You can have a structured data of independent birds going after the target. Okay. Now we can continue. Okay, so as I mentioned before, Panda Logic is a programmatic job advertising company. Okay, so if we talk about the flock of birds, in here we talk about the flock of jobs. Okay? So same as winter migration, the purpose of a campaign, of a job posting campaign, is going from point A to point B. Point A is the campaign start. The campaign starts, and point B is actually the campaign goal. You have a limited amount of money, you have a limited time, and you gotta get there. Okay. Same in flock of birds, same principle. You can talk about birds or jobs going too slow, too fast, or exactly on track. Okay, so we gotta monitor them. And the result, same thing as a flock of birds, is a campaign level optimization. Now, the big challenge was to actually take the basic principles of a flock of birds and convert them to a flock of jobs. There are differences. One of the main differences is the definition of the position of a bird. Because when you imagine a flock of birds, it's pretty easy to imagine what does it mean for one bird to go in the middle, in the center of its surroundings, and to go in the middle and to not collide in any other bird. But when you talk about a flock of jobs, what does it mean? So you gotta create a whole new set of coordinates for a job based on its goal. It already achieved performance, it passed action you took on it, and the budget it has. So you have a whole new set of coordinates in order to understand what is the position of a job or a bird. Second thing is a bit technical, but you have, for birds, you have 3 rules. So the rule of separation is irrelevant here. You don't have any problem to have 2 jobs in the exact same place, okay, unlike birds. And the third difference is what you call flight control, because if a bird wants to go right or go left, it's pretty easy. But how do you control a job? So the way you control it is by the bidding and the budget. You allocate more money, and you raise the bid when you take it outside. Okay, so when I say take it outside, as I mentioned before, we have 2 sources of getting applicants for a job. One is internal, our platform, and the second one is external. And when I take the job or export it outside to LinkedIn or to Facebook or to ZipRecruiter or whatever, it all depends on the bid, okay? How much am I willing to pay for a click? And our claim to fame is we probably can manage it better than anyone, okay? So the point is to either raise or lower the bid. Okay. Another challenge is to A/B test. One of the questions in the previous session was, how do you know if you're doing well or not? So in order to do that, we created a sort of A/B test. A/B test meaning you take a specific population and you divide it into 2 as symmetrical, as identical groups as possible in order to modify one of them and see the changes. Okay, to see the effect of the change you made on a specific group, and to have another group which is not changed, so you can control the data, the differences. In our case, the A/B test was 5,000 jobs, okay? And when you measure if you improved, if you done good, you either get more applicants for the same amount of money, or you can get the same amount of applicants for less money. So for instance, if I used to have 100 applicants for $100, the improvement can be use the same $100 but to get 200 applicants, or to get the same 100 applicants and that's it, but for $60, for instance, and not to pay the same 100. On our world, every percent of change is meaningful. So like if you get a 5 or 7 or 10%, that's an issue. In this case, this algorithm brought 46%, which is whopping. Okay, but this is our story. The main thing I wanted to share with you, this is just a single idea. The issue of biomimicry is really, really deep, and you can go and it's a whole new world. And the thing I would like you to take from this issue is to like open your mind, because you never know when your next idea is going to come from. Okay, we have time for questions now.
How did you come up with this idea of mimicking nature algorithm?
Okay, so the question was, how do you do it? The question was, where do you come with this idea? Well, 2 things. The first one is, specifically my formal education is biotechnology engineering as well as computer science. So I study this world, I'm familiar with the world of biology. Specific, the flock algorithm was presented in another summit here in Israel called Reversim. Someone presented this algorithm just like, just snapped. Okay, everyone. So once again, thank you, Omid, for the opportunity to talk. This is me. Thank you.